So we're going to take a look at 17 and 18, which are going to be really similar to number 3 as well. So first, let's take a look at number 18. So the first thing that you're going to do is you're going to graph it just like we did in number 3. So in 18, I have the point 2, 3. So that's going to be here. And I have the point 12, 3. So just to avoid hash marks because I have a limited amount of space, we're going to do this. And so I get basically just a line segment. And it's at the same value, so it's flat. So in order to get that solid of revolution and connect them across the x-axis, you're going to have a mirror point. So you're going to have a point opposite of each one. So this is that reflection piece. So I have this line segment, and then remember, to connect them, we draw a circle. So this is a cylinder. And we know that a cylinder is made up of the net of 2 circles and a rectangle. And so to find the surface area of a cylinder, I have to find the surface area of each circle plus the rectangle. So if I look at these circles, the distance from the x-axis right here to the top part of the cylinder is the radius. So if I look at the radius here, it goes up 3, so this is 3. So my radius, and so in number 3, it specifically says to draw the line to the x-axis, and that's to get you to realize that the radius of the circle is how far that line segment is from the x-axis. So I know my radius, so I know that the area of the circle is going to be 2 pi r squared. So each circle then is going to be 2 pi times 3 squared, which would be 9 times 2, which is 18 pi. And I have 2 circles, so that gives me 36 pi for my circles. Now for this rectangle, it's going to be how far these are from one another. So this was the point 2, 3. This is the point 12, 3. So they're 10 units apart. And a lot of this, guys, you have to draw it. There's just not a way to get here other than to draw it. So don't be afraid to just put a picture on paper. So the length of my rectangle is 10. And then remember, the distance from here to the axis is going to give me that width. So that would be 3. So my rectangle is going to be 10 times 3, or 30. So the surface area of my cylinder would be 36 pi plus 30. And you could type that into your calculator to get your decimal answer. Now the nice thing is that the volume of a cylinder is a bit easier to calculate. So the volume of a cylinder is going to be pi r squared h. And h we already found. H is how long that top piece of the cylinder is, which is 10. And I already found the radius when I did the surface area of the circle. So then I'm going to get pi times 9 times 10, which is 90 pi for my volume. And so that's how you're going to tackle number 3, 17, and 18. In 17, I will be happy with just the surface area using nets because it's going to be a little interesting on that one. So if you want to focus on just finding the surface area for the net, because when you sketch 17, you're going to find you have something like this when you plot those 2 points and you connect them, which means when you mirror that, you get this. And so this isn't really a cylinder because it doesn't have that straight line feature of a cylinder, but this is 2 circles that we can see. So if I had a net, I would have 2 circles and I would have a trapezoid. So you would need to take the surface area, would be the circles, plus the area of a trapezoid. So in that area of a trapezoid section, you need to look up the area of a trapezoid and add those together for the surface area. So that's what's going on when you're looking at these two problems, is that you've got to sketch it, identify the shape, and then from the shape, you're going to get to the net. And then the volume formulas are pretty straightforward with the exception of 17. So if you want to go ahead and focus on the surface area, I think that's perfectly fine.